Example 3.6. Determine the loop current Ix and the voltage Vc across the voltage-controlled voltage source for the mesh circuit. So what I want to do here is I want to talk about some calculational tips and how you deal with this. So when dealing with dependent and independent sources, one always keep dependent sources on the left side of the equal sign, always keep independent sources on the right side of the equal sign. And you'll see what I mean when I start to do that. So let's go through the process. Let's do the numbers. And in this case, what we want to do is that we want to calculate Ix and Vc. So when you look at that, you look at Vx, note that Vx is this right loop. So this is automatically going to be a loop current. And this Vc, this is going to require a solver equation. So let's set this up. So here we go. So when I look at this guy, oh, my mouse is kind of acting funky here. So I'm going to pick my loop direction. And as I pick my loop direction, I'm going to see here is that I have two current sources. And when you look at the two current sources, they're connecting three loops together. So if I look at this, I'm going to say that my number of loops, you could see that I have 4 loops and I have 2 sources. So this gives me 2 loop equations. And of course, the question is, what kind are these loops? Well, you can see here is that I have to have a super loop between this guy. So I'm going to call this one I1. I'm going to call this one I2. And I'm going to call this guy I3. Nope, not I3, but IX, because it's the same direction as that. And so then I'm going to have a third loop here, which I will label with the current direction of this guy right here, which will be I3. But we can see here is that this guy is a loop current that looks like this here. So according to the direction of Ix, we see that the loop is moving in that direction right there. So I picked the direction of Ix. So now I'm going to start my counting. So here I go. So now I'm going to start with the regular loop, which is I3. So I'm going to say that loop 3, this really has what? Well, we're just doing the counting. So I have loop 3. I see that I have a super loop. I have a super loop. So I have a super loop that connects 1, 2, and X. Then I have 2 super conditions, right? So in this case, I have a super condition. I have a super condition between 1 and 2, and I have a super condition between 2 and X. Now, if I look at my sources, I have 2 dependent sources. One is IX, one is VY. So I have 2 DCs, which will then be VX, nope, not VX, IX, and VY. But wait a minute, we just chose IX as one of the loop currents, so we don't need that because that's just IX equals IX. So we don't need a DC for IX. And finally, we have a solver for VC. So when I do my counting, what do I see here? I got 1, 2, 4, 5, 6. So I have 6 equations, 6 unknowns. And so that means I'm going to have I1, I2, I3, IX, VY, VC. So there we go. So let's get started here. So I'm going to have to put in the circuit again over here. So I think what I'm going to do here is I'm just going to highlight this guy. I'm going to copy this and bring it over here. So it's just easier to write down the equations. Okay, here we go. So now that I have that, now I'm going to look at that. So here's my first equation now. My first equation is going to be the regular loop at 3. So you could see that I have 3 resistors, and note that I have a dependent source. So here I go. So I'm going to add up all the resistors, which will be 1 plus 2 plus 1, and this will be I3. And now look at that. I have 2 mutuals, one with 1 and one with 2. So then I'm going to write minus 2I1 minus I2. Now look at this dependent source. So as I come across with KVL, I see a minus sign. So I'm going to write minus 3IX. So note, I keep this on the left side. I don't move it over. No current source, no voltage sources, constant voltage sources. So that's 0. Okay. Now let's look at the super loop. So if I look at the super loop, this is between 1, 2, and X. Here's what I'm going to write. So the first loop, note that I only have 1 resistor. So that should be 2I1 minus 2I3, right? So right here is loop 1. Then I go to loop 2. I only have 1 resistor between 2 and 3. So this should be I2 minus I3. And then I have my last loop, IX, but there's only 1 resistor. So then this should be 2IX. And this will be loop X. So now let's go around the loop. So if I come here, look what I'm seeing. Note that as I go around the loop, I have that 3IX. So as I come around, you're going to see that I get to the 3IX. That gives me positive 3IX. Again, what do? I want to keep my dependent sources on the right. But as I come around, I now come to the positive 2 volt. I need to take it to the other side, so it's positive on the left. When I take it to the right, this becomes minus 2. Again, I keep this on the right side because that's where my constants are at. Now let's go to the supercondition. There's two of them, right? The first supercondition is between 1 and 2. And if you look at that, there's the 9 volts. So note that I2 is in the same direction as the 9 volts. So this should be I2, I1 equals 9. Now let's look at the supercondition between 2 and X. So if I look at this guy, here I come. So note that the 2 is in the same direction as the 2Vy source. So 2 is positive, but remember, this is a dependent source. So it has to go on the left. So here I go. So this is going to be I2 minus Ix. Now I want to take it to the other side. So this becomes 2Vy equals 0. So there's my fourth equation. So now I need a DC. So I need my DC for Vy. You can see that Vy is connected to the voltage across the 2 ohm resistor. So then I'm going to see here, as you can see that I3 is positive, I1 is negative. So I'm going to write this as minus I1 plus, oh, that can't be right. I have to write minus 2I1 plus 2I3 minus Vy equals to 0. Okay, and then finally, I need my sixth equation, which is going to be my solver for VC. So let's look at my solver. So what I'm going to do here, I don't know, I could take the loop of I2 or I could take the Ix. I choose to take the Ix because I know the voltage across the 2 ohm resistor and I have that dependent source up there. So what I'm going to do here is that I'm going to apply KVL around the left loop. So let's look at this thing. So if I do that, this is what the left loop looks like. So I have my dependent source, which is 3Ix. And then I have my node VC right there. And then I have my current source, which is 2Vy. So what I'm going to do here is that I'm going to pick this guy right here to be my ground. By doing that, this is what I see. You could see that VC is really the voltage of this 2Vi source here. So I should have done this before, but I didn't. So this is the polarity here. So I know that this is my current that goes like this, right? This is Ix. And then I'm going to pick my loop in this direction so that it goes like this. So if I pick that direction of my loop, you can see then I'm saying that this is positive and this is ground right here. So here I go. So if I look at that, let's say I start at VC. So the voltage across the 2Vy, let me be careful here. So this guy has to be the voltage across the 2Vy. So if that's the case here, starting at VC, I'm going to get VC minus 0. And then I come around and I get the 2Ix, and I keep continuing around and I get the positive 3Ix. And you could see that this is VC plus 5Ix, and that's equal to 0. That's my solver equation. So what I'm going to do here is that this is going to be a mess. So I think I'm just going to copy these equations and bring them down. So I'm going to take these equations and I'm going to clean them up just so that you could see my organization. So what I want to do here is that I'm going to matrix up this bad boy. Okay, so I'm going to start putting in my equations so that they look like this. So I'm going to get rid of some of this stuff here so that it's just easier to see. But you could see here is that, yeah, I'm going to get rid of these two. This is just for organization. So this is my equation 1 right here. This is my equation 2. This is 3. This is 4. This is 5. And then all I need is 6. So 6 is right here. So let's go grab this. I'm going to copy it right here. So now all I got to do is just put all these guys together into matrix form. So let's do that. So then I'm going to use a color scheme to organize my thinking. So here I go. Right? So I'm going to put in my I1. Maybe move it over a little bit. I1, I2, I3, IX, VY, VC, and then I'm going to have my constants over here. So let's focus on I1. So an I1 is right here. Okay, I dropped some signs on equation 5. So equation 5 has 1 and 3. So this is 1 and 3. So you could then see that I have this guy right there. So now I'm just going to start writing them down. So if I look at I1, I'm going to write minus 2, 2, minus 1, 0, minus 1, 0. Now I'm going to focus on 2 here. So if I focus on 2, I got 2 here, 2 there, here, here, and that's it. So if I look at the first one, this is going to be minus 1. I'm going to get plus 1, 1, 1, and then I should have 0 and 0. Now let's focus on I3. So if I focus on I3, I have I3 right here. And right here, all the other places are 0. So now let's look at that. So let's be a little bit more careful. So this one has 1 plus 2 plus 1. If I go to the next one, look what I get. I get minus 2 and minus 1. So this should be minus 3. Then I get 0, 0. Then I get 2 and 0. So now if I focus on IX, I get IX here, 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 and then right here and right there. So again, being careful here, this is going to be minus 3. Now look at that. I get 2 plus 3. That gives me 5. So I'm going to put 5. Then I'm going to get 0, 0, minus 1, 5. So now where is VY? So if I look at VY, VY doesn't occur until it gets to this DC right there. So everything is 0 except for that fourth equation here. So I'm going to come to the fourth equation. So the first 3 are 1, 2, 3. So I'm going to go 1, 2, 3. Then this becomes minus 2. And then I get 0, 0. VC only occurs right here. So if I look at that, I only have one right here. The rest should be 0. So here's my matrix. And now I got to look for my constants here. So I'm looking at everything on the right side. So I see that the first term is 0, right? Maybe I go like this. That's 0. This is 2, 9, 0, 0, 0. So I get 0, minus 2, 9, then 3 zeros. Okay, so now I have my matrix. So then if I now put this into my calculator, I then get the matrix magic, which then tells me that Ix is equal to minus 1, that looks like 1 amp, negative 1 amp, and Vc is equal to 5 volts.